All right, 5.6. A couple new rules here. ASA and AAS. So you can pretty much assume what those are going to be. Angle, side, angle, and angle, angle, side. Okay. So with ASA, we have one angle marked here, one angle marked here, and then we have a side, and that's the included side. In other words, that's the line that connects the two angles. So if we're talking about angle A and angle C, the line segment is AC. All right? So that's why we have angle, side, angle. And again, I really suggest you label them because you'll see right there, there's my rule. So I come over here, I go, there's an angle, there's a side, there's an angle. It reads right in order. Okay, can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. So first off, we have a bunch of parallel lines. We have this parallel line, this parallel line, this parallel line, okay? And then we have a transversal coming through. So this takes us back to what we've done for quite a while now, all right? So what do we have going on here? We have angle 3 and angle 1 are alternate interior angles. We have angle 4 and angle 2 are alternate interior angles. All right. We also have a side right here that is congruent to itself by the reflexive property. So we have an angle here that corresponds to this angle. We have a side, and we have an angle here that corresponds to this angle here. So what do we have? Yes, by ASA. Now we also have angle, angle, side. So notice this time the side is not included. So if we look, do our little trick here, angle, angle, side, angle, angle, side. Okay, it's a non-included, but it has to be the same non-included side. So for example, if it's this one over here, it cannot be this one on over here. Okay? So they got to line up, they got to match. So if you notice over here, this is the side coming from the angle with the 2 mark. Over here, this would be the side coming from the one with the 1 mark. It can't be the same. I mean, it can't be different. It's got to be the same one. All right, can the triangles be proven congruent with the information given in the diagram? So you see here we have angles marked, okay? We also have unmarked those angles, and we also have these angles, okay? So right here, we have an angle, and a side. We have angle, angle, side. So that's yes by AAS. Okay, on B, we have angles all marked, all right? But there are no sides given. And without that, we do not have enough information. We need a side, okay? There is no angle, angle, angle rule, okay? And the reason is there's no angle, angle rule is because if I have this and I have a bigger version of it and these all match, then that does not mean they're congruent. All right, we'll get to that later in this class, but that is why angle, angle, angle does not prove congruency. They can have the same angles, but different size lines. All right, what do we have here? We have an angle that matches up with this angle. We have an angle here that matches up with this angle. And as always, we mark the reflexive side that is equal to itself. So yes by ASA. All right, nice easy proof. So what do we have here? We have AD is parallel to EC, which we already have marked here. Okay, let's extend that line so we can see things a little bit easier. We have a couple transversals, but we're going to be worried about this one right here where it's marked that BD is congruent to BC, and those are already marked also. That's given. Okay, so if you think about these triangles, kind of like hats, the pointy end of the hat is up here. E matches up with A. D matches up with C, if you can see that. All right, so if we have a transversal and we have these parallel lines, that means this angle right here and this angle right here are congruent to each other. So angle C is congruent to angle D because they're alternate interior angles. Now we also know that this angle right here and this angle right there are congruent because of being vertical. Now we can't just say angle B because there's a lot going on there, so we have to be careful. So I'm going to start at the tip of my hat, ABD. So angle ABD is congruent to angle, I'm going to start at the top of the hat, EBC. All right, and we say vertical angles are congruent. And then look what we have here. We have an angle, a side, and an angle. We have an angle, a side, and an angle. So we're done. We can just say triangle ABD is congruent to triangle EBC by ASA. Easy peasy. All right, another one. We have HF is parallel to GK. Okay, that's marked right here. This line, this line. So let's go ahead and go back to what we know. And here's our transversal here, right? All right. Then we're also given that angle F and angle K are right angles. Those are both given to us. Now, since we have parallel lines and transversal, we know that this angle right here, whoops, and this angle right here are congruent. Alternate interior angle. Oh, oopsie. That's the same triangle. That was silly. This angle right here are alternate interior angles. Alternate on the other side of the line. All right. So I'm going to name these. I'm going to start at the right angle to be just as a point of reference. So angle F coming down to H and going up to G is congruent to angle starting at the right angle K going to G and down to H. And I say that by alternate interior angles. Right? Then we know this side is equal to itself always. So we say GH is congruent to GH itself, and that's the reflexive property. And then we're going to say angle K is congruent to angle F. Right angles are congruent. So what do we have here? We have an angle, and then an angle, and then a side. We have an angle, and a side. So now we can say that triangle HFG is congruent to triangle GKH by angle, side. You're just getting the pieces. All right? So, next one. We're given angle S is congruent to angle U, and RS, line segment, is congruent to VU. Everything is marked on here. Looking at this, we already know that this is going to be congruent to itself, right? Not to itself, sorry. It's congruent by vertical angles. So I'm going to say that. Now, got to be careful here. So I'm going to go like road maps. So R has no angle mark, S has 1, T has 2. So I'm going to say angle R, T, S. So I'm going from none to 2 to 1. Is congruent, I got to start the no angle V into the 2 and then to the 1. Oh, I forgot to write given, sorry. All right, and I can say that again, vertical angles are congruent. And believe it or not, we're done. Because here we have an angle that matches up, and we have an angle that matches up, and we have a side that matches up. So we can say triangle RST is congruent to triangle VUT by AAS. All right, exit ticket. Which card does not belong? Write an explanation for your choice.